Welcome back to The Explainer. I am so thrilled you're joining us today because we're going to be tackling one of the most elegant, satisfying concepts in economics. We're going to map out exactly how price elasticity interacts with total expenditure, and we'll be doing this using a really classic framework known as Marshall's total outlay method. So if you've ever wondered how economists and businesses actually visually map out consumer responsiveness to different pricing strategies, you are in the perfect place.
Right. Let's dive straight into this with a really practical business puzzle. Imagine you're managing a product, and lately sales have just been a little sluggish. Your immediate gut instinct might be to just put it on sale, right? But here is the critical question. Does lowering prices always mean lower total expenditure from your market? Like if you drop your price, are you absolutely guaranteeing a drop in your total revenue? Your intuition might be screaming yes, but economic science says, well, it depends. And it depends entirely on elasticity.
Here's our roadmap for today. We'll start with the pricing revenue puzzle, take a look at the elasticity matrix table, trace the actual expenditure curve, and wrap things up with the method's final critique.
Let's kick things off with part 1, the pricing revenue puzzle.
Okay, so let's nail down the two foundational variables we're going to be using throughout this explainer. First up is total expenditure, which we're going to tag as TE. This is simply the price of your product multiplied by the quantity demanded. Literally, it's just the total amount of money consumers are spending on your product. Second, we have the price elasticity of demand, tagged as EP. This measures the degree of responsiveness. Basically, if you change the price by a certain percentage, how big of a wave does that create in the quantity demanded? Our main goal here is to figure out exactly how EP influences TE and, ultimately, your bottom line.
Moving right along to part 2, the elasticity matrix table.
Now, take a look at how this matrix elegantly maps out the complete relationship. Let's look at the columns first. We've got unitary elastic, relatively inelastic, and relatively elastic. And then for the rows, we have a fall in price or a rise in price. Notice something really interesting here. When demand is relatively elastic, a fall in price actually causes total expenditure to rise. But look at the next column over. When demand is relatively inelastic, that exact same fall in price causes total expenditure to fall.
To make this matrix super easy to remember, especially if you're that manager we talked about trying to boost sales, we can distill the whole thing down into 3 golden rules. First, when EP equals 1, total expenditure remains completely constant no matter what you do to the price. Second, when EP is less than 1, meaning it's inelastic, total expenditure moves in the exact same direction as price, so price goes up, TE goes up. And third, when EP is greater than 1, meaning elastic, TE moves in the opposite direction as price, meaning if you drop the price, your total expenditure actually grows.
All right, let's take this to the graph in part 3, tracing the expenditure curve.
Before we actually look at the curve, we really need to pay attention to these axes, because honestly, they might trick you. A standard demand curve usually has quantity on the x-axis, not here. For this specialized total expenditure curve, the x-axis measures total expenditure, or TE. The y-axis measures price. So as we move horizontally to the right, total consumer spending is going up. And as we move down vertically, the price is dropping. Just make sure you keep that geography strictly in your mind as we move forward.
Okay, the curve we are mapping out is referred to in the source material as the T1 curve. And to really understand it, we're going to break it down into 3 distinct zones. Zone 1 starts at the top from point T to point A. Zone 2 drops down from point B to point C. And Zone 3 traces from C down to T1. Let's walk through these step by step.
Starting up top in Zone 1, which spans from point T down to A. Now we see something pretty counterintuitive here if you aren't thinking about elasticity. As you trace the curve downwards, meaning, the price is falling on the y-axis, the curve actually slopes outwards to the right on the x-axis. Total expenditure is increasing. So as a manager, dropping the price here actually makes your total revenue grow. Because price fell and TE rose, meaning they went in opposite directions, we know mathematically that demand in this zone is relatively elastic. EP is greater than 1.
And this brilliantly illustrates unitary elasticity as we transition into Zone 2. Just look at the behavior of the curve between points B and C. It stops sloping outward and instead drops straight down in a vertical line. As we continue to drop the price down the y-axis, our position on the horizontal x-axis, our total expenditure, literally does not budge. For a business, this means putting the product on sale leaves your total revenue exactly the same. Because TE remains unchanged despite the price drop, elasticity right here is perfectly equal to 1.
Finally, let's slide down to Zone 3. From point C down to the bottom point T1, we keep slashing those prices. But now, the curve bends backward. As we move down the y-axis, we're being pulled to the left on the x-axis. Total expenditure is shrinking. This is exactly where that manager's intuition fails. Slashing prices here directly hurts overall revenue. Because a fall in price results in a fall in TE, they're moving in the same direction, we know that in this lower zone, demand has become relatively inelastic. LEP is less than 1.
To really cement this visual map in your mind, let's just put them side by side. In Zone 1, at those higher price points, dropping the price actually makes you more money overall. Price falls, TE rises. Opposite direction. But keep slashing prices all the way down into Zone 3, and dropping the price destroys your overall revenue. Price falls, TE falls. Same direction. The T1 curve literally proves visually what that matrix taught us conceptually.
Which brings us to our final section, the method's final critique.
As elegant as this whole map is, the source material gives us a pretty crucial reality check. It explicitly notes a fundamental limitation. This method provides only a general, non-exact measure of elasticity. Think of Marshall's total outlay method like a compass, not a GPS. It'll absolutely tell you if elasticity is greater than, less than, or equal to 1. It tells you the general weather, sure, but it doesn't give you the exact temperature.
So that leaves us with one final, pretty vital question. If the total outlay method only gives us a general direction, how on earth do businesses find the exact coordinates for perfect pricing? Well, to figure out whether an elasticity is exactly 1.2 or 2.5, you have to leave Marshall's method behind and explore completely different tools, like the point method or the arc method, which calculate those exact percentage changes. But hey, that is a journey for another explainer. I really hope the structured look at the elasticity matrix and the expenditure curve has sharpened your economic intuition today. Thank you so much for joining me. Keep studying those concepts, and I'll catch you next time.